I guess I will start.
Yeah.
Hi, everybody. Good afternoon. My name is Husam Barham. I'm from Portland State University. I'm a PhD student at the Technology Management Department. I'm presenting a paper about my research. This paper is written with my supervisor, Professor Tuguletti. He wasn't able to come here today. He's the chief editor for the IEEE Transactions for Technology Management. And as it happened, their annual conference is happening now in Germany. So he apologizes for that. So I'll be presenting this research today. It's about what are the critical issues when we are doing a big data project for smart cities. What are the things that affect doing such projects and making sure that to understand those things to increase the chances of successful for such projects. I will do some background. I will introduce my research questions, my findings, and then I'll wrap up. Try to do that as fast as possible. So the first thing is I'll touch a little bit about the background. So what is smart city? Obviously, there is no unified definition of what smart city is. And in Tuesday's workshop, somebody said that for different cities, a smart city mean different things. But for the industry is trying to define what is a smart city because that's easier for them to work around. This is a picture from IBM. And what industry like IBM and other vendors suggesting is smart city should be around three things about how do we plan in the city, how do we handle the infrastructure of the city, and how do we deal with the people in the city. And the idea is that around the city there is an infrastructure, physical infrastructure, IT infrastructure, there is social infrastructure and business infrastructure. And the total of that infrastructure is far larger than the subcomponents of it. So smart city aim is how can we aggregate those resources together to achieve sustainable economic growth, high quality for people, and how can we wisely manage the resources of the city. So this is like a very broad definition of what smart city is. And then when you go down, you'll see that each city is doing their own definition and their own projects around smart cities. But the main idea, I think, what I saw in this conference yesterday, many people were talking about the high quality of life. How can we increase the quality of life for people around the city? That means economic stability, jobs, housing, maybe better traffic, reducing the environment costs, around and other things. So, smart cities and big data. Big data is in the heart of smart city. Smart city is based on big data, and big data promises that we can leverage the data around the city to come up with the insights and analytics that allow us to better manage the city. Things like when we talk about intelligent transportation systems, smart grid, smart safety, smart education, smart health, and so forth, you name it. All those kinds of smart systems based on the city, connecting all the infrastructure and the data city to come up with those things. So the heart of that is big data. And when we talk about big data, we are talking about IoT. This thing is barely working. We're talking about IoT, about data coming from core systems within the city, about social media feedback, about logs whether on the internet or from systems, also about public records and records coming from other entities within the city or outside the city, all those kinds of data surrounding the city, and how can we leverage big data to analyze those things and get insights from them to enhance the quality of life in the city. What is big data? Again, there is no unique or unified definition about what is big data. But if we look out for literature in the last few years, people, when they talk about big data, they often refer to one of three things. They usually talk about big data as an entity. That's saying that data that because of unique characteristics within the data, it's not easy to analyze it using traditional tools. Things like the volume of the data, variety in the data, velocity, more recent veracity also, and value, and so forth. Big data is data that is either structured or unstructured, data coming from internal or external sources. So that what is called big data as an entity. It is where the term came from. Then there is what's called big data as a process. It is the idea that having an information system along with its infrastructure to collect this data, to absorb this data, to acquisition the data, then to store it and analyze it. And under this arrow acquisition, there is a huge discipline talking about how can we read the data from sources, how can we cleanse the data, how can we enrich it, how can we enhance it, how can we unify it, then how can we aggregate it in a format that is suitable for our analysis, then how to store it in a way that allow us when we need to analyze it or retrieve the data, it is ready for that, and then introduce the analytics behind the data. So that's usually referred to as big data as process. Well, I will be conservative about usually, but many research call it big data as a process. When somebody says we are investing $20 million to build a big data project, usually they are talking about this. Then the final definition that is very, very frequent in literature is big data analytics. And that's talking about using insights from the big data, and that's where, of course, smart city is coming, that I need to build analytics and insights to make better decisions for my city. And when we talk about big data analytics, again, it's coming based on the data generated here. And when you hear somebody saying, well, we use big data and now we have 15% enhancing our efficiency, we are doing 20% better in our performance, they are talking about using this big data analytics. But the term is fuzzy and people use the term big data for many things. In my research, my focus is in this area. So when we talk about big data as a process, building a software system along with this infrastructure to be able to consume and take the data from here, format it to a thing that is suitable for our analytics. How can we do big data projects, how do we implement big data projects to build those systems? This is the area where I am focusing. And this is more details about that. Big data projects the idea is to create or enhance the capabilities of a city to be able to have insights from the data surrounding the city. Now, what is my research motivation? There is a problem with those big data projects. Now, this is a general trend, not just for smart cities, big data in general. Studies suggest that 50% of those projects never succeed. They either never complete or they don't generate value for business. And in fact, that did not start with big data. Before big data, maybe in the early 2000s, 90s, there were what was called BI/data warehouse, maybe the grandfather of big data, I would say. And it has the same problem. There were also a high percentage of failure for those kinds of analytical projects. And there is a plethora of research about why those projects tend to fail. And if you just do some research in Web of Science, Compendium, Google Scholar, you will find a lot of research starting maybe 10, 15 years ago until today about why those projects tend to fail. Nevertheless, they still fail. And people still have cities and, of course, in general, big data projects have high percentage of failure. So what are my research questions? What I'm trying to achieve from this research? First, to say that what is the big problem about that? Since big data projects have a high failure percentage, that come with a cost. Those projects are very expensive. Also, while doing those projects, you need to assign the best resources in your organization that you would utilize somewhere else. In the case of cities, that is even more of a problem. Also, you become a competitive disadvantage. So other cities who successfully implemented smart city-related big data, quality of life enhanced there, for example, the traffic is better for them. Just because they are using big data, you are not using it, you have worse traffic, people will leave your city, go there, or maybe the pollution and other kinds of things that they are benefiting of successful big data, you are not. So there are severe consequences for the failure of big data, more in the case of cities. So my research is first, what are the critical reasons for failure of coming big data projects? How can we assess a city's readiness against those things? So before we jump in and start the project, we will go there with confidence, knowing that, yeah, we could be successful in this project, or we would say, no way, this project will not go through, so let's not waste our money. And then what kind of corrective preventive actions can we take in to prepare ourselves for those projects? Okay, and my research focus lying in this area here in the middle. So when we select any project in general, that also apply for big data projects, for smart city projects, any kind of project, there is first the process of selecting a project. We look for what kind of projects we need, what gaps we have, what strategy goal are we trying to achieve, then what kind of projects we need to do to achieve that. We go for our criteria selecting, looking for our portfolio, until we come to a point where we select a project. We say, we have budget for this project makes sense for us, that we go ahead and do it. Then we start doing the project itself. We initiate the project, then we go to the cycle of planning, executing, controlling. If you are waterflow, just planning directly to this phase. If you are agile, yeah, it is a circle until you are done with the project. So my focus area is in between. We selected the project, we say we have fund for that. So I'll say, wait a minute, let we make sure we are ready to do this project, what kind of capabilities the city have against the needs of this project, and are we ready to do it? Can we do improvements and go in a cycle of improving, checking again until we feel that we are in a state that most likely the project will be successful, then you go ahead and do the project. Okay, and I conducted a lot of literature review to try to identify what are the reasons for failure for big data, and I find that, again, there is a plethora of research. It's easy to find at least, I think I scanned more than 2,000 papers. I critically read 200 papers. Of course, nobody can read 2,000. I just go through them, but at least critically reading almost 200 papers. I found as a pattern that most papers that talked about reasons for failure of big data, they are either surveys. They survey CEOs, IT managers, technical people on the ground, and find why those projects fail. There are also papers about experience. Either an expert in the field will write a paper about their experience, or they will conduct series of interviews with experts and came up with why those projects seem to fail. There is literature review, of course, reviewing those things along with literature from other disciplines to come up with reasons for those projects to fail. And there are also nice papers like case study papers. We'll find a city conducting a project and analyze this project, what went wrong, what went well, what are the lessons learned from that. There are a lot of resources when you talk about those papers, a lot of research, I would say. However, the problem is there is limited research about how can we, in a vigor way, in a structured way, in a deep way, analyze our situation, make sure that are we ready or not against those reasons. How can we, in a systematic way, identify our capabilities against the upcoming project to make sure that can we do the project or not. This is the gap that I am targeting in my research. And to go through those reasons, I could categorize the reasons that could present challenges for projects, cause those projects to fall into 4 perspectives first. There are the people perspective, the technology perspective, the legal perspective, the organization perspective. And as just I was talking with Dr. Taft a little bit ago, that some people think that, well, those projects fail because of technology issues. No, technology reasons are some of the reasons, but mainly, especially when we talk about larger scale projects, usually other factors, again, external factors around the projects are the reason for failure for those projects. Technology is one reason, but it's not the main reason, not always, not in most cases. So when we talk about people perspective, when it comes to big data, there are things related to the skills of people and how does that affect the upcoming project. When we talk about technology, it's technology, the challenges of big data being of a huge volume, coming fast, the authenticity of data, the various sources of data, and how can we have what kind of technology challenges around that. Then there is the legal perspective. Big data include getting data from sources generated into the recipients. So there are legal issues about getting data from sources, other legal issues about delivering this data to recipients. How can we handle those? How does they affect the project? Then obviously there are organizational perspective things. What are the things going on inside the organization, inside the city can affect the project to be successful or not? There are many reasons. Under each category, I will just show the main ones, the ones that seems critical from literature review. First and foremost, data scientists. When we talk about people perspective. So for big data to make sense, you need smart people that we call now data scientists. We give them a name. People who could understand the data, could understand the technology, and could understand the business and realize what kind of data this is there around the organization and how can I analyze this data to generate value that makes sense for my organization. The problem is there is limited number of those data scientists and they are very expensive. Then there is the employees' technological skills. So there is this term in IT, garbage in, garbage out. So if your employees are not feeding the systems that you are relying on in a proper way, those systems will never generate meaningful insights. If the data coming is wrong, well, the system will not come up with its own data. It will analyze the data available to it. There is also the management analytical skills. So there's a lot of literature about this, and I saw this from my own experience, projects I was engaged in. You build this very, very amazing, smart project, and you show it to management. They are happy about that. They will have like a big screen in their room and show all those dashboards there, and that's it. At the end of the day, will say, well, I am following my gut. I don't believe in those things, but if somebody visited me, I will show them those nice graphs to look cool and look progressive or something. But at the end of the day, they don't understand it, they don't use it. So what's the point of building the project? Now, technology perspective, there are some things, challenges around the data itself that cause those projects sometimes to fail. Again, the most important one is data integration complexities. So we are reading data from multiple sources for big data to make sense, and being different from data from one system you are using. If you have a core transaction system, some reports on the top of that system, what big data is offering to you in more than that system is the ability to read data from multiple systems, aggregate it, and generate insights from that. The problem is data from multiple sources have different metadata. As in the workshop, Dr. Meyer, you corrected them about the metadata thing. So yeah, so metadata sometimes different from among different kinds of data sets. Sometimes when you talk about social media, there is no data, no metadata, it's unstructured data. You put a hashtag about your new product, people comment on that, and somebody will say, great. Well, are they sarcastic or they really think it is great? How can you analyze this sentimental factor within the data? So integrating the data from multiple sources sometimes could be a reason for failure for the projects. Then there's data availability. So big data promises to make the right decision at the right time. You need the right insights. But maybe data is there, but it's not available at the right time you need it, not immediately, not live data, maybe not daily data. You need it daily, but it is generated monthly or something. Then what kind of data to collect? There is a huge amount of data being generated today, and again, that's related to data scientists. Should we collect everything around us, but that consume a lot of resources? Should we collect a limited amount of data, but we are losing insights? So how can we strike this balance? And then final one is technology solution complexities. Big data is a fairly recent discipline, I would say, from technology perspective. There is not like an Oracle package for big data or IBM package for big data. There is first Hadoop, and then there are many projects and tools around that. And as more complex your project become, the more tools you are using, and then you start to face compatibility issues between those tools. And you face problems where you need really smart people to be able to integrate those tools and make sure they talk to each other correctly. Now, legal perspective. Again, legal, we are talking about the people who generate the data, people who receive the data. And the first problem is external sources of data. So I have, for example, access to 90% of the data. Then there is this 10% that glue everything together and allow me to create real insights from it. But the source of this data says, no, I will not share this data with you. So one of the challenges of big data is there are many data sources that are critical to the value of those systems, but the owners will not share those data with you. And what should you do about that? How, for example, negotiate with them or create some sort of mutual benefit for you and them to encourage them to share the data with you. Going further with that is data ownership. So some data sources will share the data with you, the owners, but they say, okay, we are sharing the data with you, but don't give any insights based on this data to our competitors. And then that kills the value of the system. Suppose we are doing something for health, and I will tell each hospital that I need your appointments data and the patients visiting your hospitals and the clinics data. Says, okay, we'll share that with you, but any analytics you build on that, don't share it with other hospitals. But the idea for me, I need to make sure that how can I distribute, for example, patients evenly, how to look for better quality of service for the customers. So if I cannot share that with other hospitals, what's the point of the system? So sometimes that could be a real challenge. Then obviously data security and privacy, especially privacy. The more you need to make sure that you are maintaining the privacy based on the data, the more the data lose value. If I cannot generate value from the system unless I expose the identity of people, then that's a problem. Saying that I need to monitor individuals. So if somebody is, for example, in the street and they have a heart attack or cardiac arrest, and my system through sensors will identify this person and send a 911 ambulance for them, for example. But no, people will say, no, don't identify me personally, don't read my vitals. So then I cannot build that system. There is this famous case about Target and their system that find out that a teenage girl was pregnant, and they send her a letter saying, congratulations, here are some discounts. Her father found from that mail, and then he sues Target. Their system was smart and found based on the patterns of purchase of that teenager that she's pregnant. But they have to scrap the system because now the system allowed her father to know about it while she did not plan to tell him, for example. So it was a smart, good system, but it wasn't able to maintain privacy and the system failed. When it comes to cities and public sector, there are legislation adaptability issues. Cities don't have as much flexibility in dealing with data. There are a lot of regulations around how to keep the data, how to collect it, how to disperse it. So if there are any legal problems, any legislation problems within the city and they cannot pass laws as fast or as flexible, so their system will fail. Finally, organizational perspective. First and foremost, management support. Obviously, any project, any change in any organization that come up with a major change to how the organization is behaving will be faced with resistance. And that's even more evident in public sector and in cities. And if you don't have management support, when you introduce a new big data system, says there's a new way to make decisions, to plan the city, to do things, people will fight you. If top management don't believe in your project and they're ready to support you, the project will not go anywhere. Data strategies and governance. Some surveys and studies suggest that 80% of the employees are getting employees are getting that, access to data that they are not authorized to do. Almost 80% of the data is being accessed by people who are not supposed to access it. And then 80% of the time of the analysts and data scientists are waste finding sources of data instead of analyzing the data. When we have strategies and governance for our data, we'll know who can see it, who can have it, what does it mean, how can we discover it, and that may mean more efficient use of data and success for our project. Finally, clarity of objectives. This is a curse for all kinds of IT and new projects. Usually when there is a hype, a new word, everybody will jump in. We need to look cool. We need smart city. We need big data. A few years ago, we need a smart app. We need our services to be online. But why are you doing that? What are the benefits? What is your strategy? And how is this project supposed to help your strategy to achieve your projects? What kind of problems are you facing that this project is supposed to help fixing? If those things are not answered, the project is doomed. It's a waste of time. There are other things, but based on my literature review, I think those are some of the most important things that should be considered as crucial factors that cause projects to fail. Now, the paper we presented to the conference stopped here. It's a literature review of those things, but I will go further now and present my model. I am now in the process of working on a model to answer this challenge. And hopefully I have time. Well, hopefully in less than 10 minutes, I will be presenting my model and hopefully get feedback about it. So here is my model. It's a hierarchical model where I'm saying that is the city ready to implement a big data project? Here are our perspectives. Here are the criteria, the things that we need to check that are we ready against or not before going and doing the project. For this model to make sense, it needs two things. First, those things are not equally important. There are criteria in those boxes. The purple ones, I'm not sure, took purple from your... Yeah. Okay, so those purple ones, they are not the same important. We need first to recognize that this is a complex issue, and maybe data scientists are a more important factor than employees' technology skills. There are various levels of those things. So the first thing in this model is we need to identify weights to say what is more important than what not. Then the other thing, in this model, I'm suggesting that the city need to find how ready are they against each of these criteria, those criteria. The thing is, it's not 1-0 or binary. The city would have some capabilities against each of those. So we need in our model to be able to capture that, to say that, well, I am 20% good against this, or I'm 70% good against this. It's not 0-1, or either you have it or you don't have it. So how can we do that? And to do that, my methodology is HDM methodology, hierarchical decision model methodology. I will not go in deep in that. I will just jump into the results to show you how does it work. But what I would say that this methodology depends on forming expert panels and then elicit the subjective judgment of those experts using what pairwise comparisons, turn that into quantitative values, and based on that generate the weights for our model. And this model have value because we could assess the disagreement among experts, inconsistency, analyze for sensitivity to have confidence in the model we are generating. Okay, my research is basically first, I'm conducting literature review to identify critical reasons for the failure, developing my HDM model, then forming an expert model, experts panel that will validate my model, says, yeah, all those are the crucial things, or you missed some things or not, and then using the panel to quantify the model, and then based on that, conduct some analytics and find out is the city ready or not. I always joke that I hope to graduate before I look like this. So let's see. Okay, I will not go through this. If there is time, we could back to it, how the model is working, but I want to show the final result to give a sense how the model works. So under this model, I have a pilot expert. In the last few months, I worked with them to create a pilot results and show how the model works. My experts find out that first, I ask them to weight the perspectives. As you can see, the percentages here, saying that people and technology, they find them as the most important perspectives, then organization, then legal, as you can see from those weights for each of them. And then for each criterion under each perspective, they are identifying the local weight. I multiply this by this with, and I come up with the final weight for each criterion. So as we said, for our model to make sense, first we need to recognize that those criteria is not on the same weight. There are relevant weights for them. And then my model will look like this, saying that, as you can see, data scientist is 10% of the overall score. If you are saying that, am I ready for a big data smart city project or not? 10% of that factor, for example, is data scientist. For example, 6% of that is complexity. Only 4% is legislation adaptability. 10% is management support, and so forth. So that's the first thing. I find now weights for this model, and I recognize that they are not on the same level. Next step is, as we said, it's not binary. It's not like the city have data scientists or don't have data scientists. They have a score against each of those these criteria. So how can we find this score? Here, where I am using desirability curves, or you could call it value curves, we are helping the city, give them guidelines. We say in my model, for each criteria, each box here, the city should have a score between 0 and 100. So based on what you are giving the score, where I created curves, those desirability or value curves for each of those boxes, and say here are guidelines. If the city don't have data scientists at all, your score is 0. If you have data scientists who strongly understand your business goals, you have 100 points. And here are values in between. For example, some cities would have software engineers with statistical skills. Some cities will have business analysts with statistical skills and some IT background. Some cities will have data scientists, but who are not really related to my core subject, and now they need to learn about the subject of the project. So there are scores for each of those, and we'll ask the city now, you decide we need to do this project. We have this model. Now we need to score you again against each criteria in the model. Go ahead, use those curves to find what is your score against each of those. Of course, I can't show you all of those. There are 16 of them. Those are just samples of them. But there is the final results. Suppose we have a project for City of Portland. Let's call it XY project. And then I will go ahead for each criterion, evaluate the readiness of the city, and come up with the scores. So for data scientists, I'll say, well, their score is 58. For employees technology, their score is 74. And I will go for that, between 0 and 100. Then I multiply that score with the global weight, with the weight of that criterion, to come with the final weight for the city. Aggregating those will come with the city score. So I'll say for the project XY, City of Portland score is 57. The score itself is not really what add value here. What add value is understanding why this score. So the things are in red color, pale red color, if you will, are the things where the city scored very low. I say, well, in data integration complexity, out of 7, the city just scored 1.89. So that's a worrying factor. Here, when we talk about technology complexities, the city just scored 1.44 out of 6. For example, for management support, they scored 5.7 out of 10. This is less worrying, but it's worrying. So looking for those scores, we go for this cycle. Again, this chart we showed earlier. And I see, are we ready? We look for this. And then we do a lot of improvements, trying to fix those things where we are scoring low. Then we call the model again, evaluate our new status. And we keep doing this until we have a reasonable score and we feel that now we are ready to do the project. Then we jump in and do the project. So that's the model I'm trying to develop that cities could use before each big data project, and to make sure are we ready for the upcoming project and enhance our chances in doing the project. Just to wrap up, my research findings mainly is that there is a need for a structured way to understand what are the managerial and project management issues surrounding big data projects, especially when it comes to cities. We need to understand those things, make sure are we ready for them, how can we thoroughly and in a structured way understand our readiness for those things. Because readiness assessment is very crucial, especially if there is high uncertainty and we know that those projects tend to fail. And when it comes to cities have limited budget and resources, this has even become more important for them. And with that, I conclude. Any questions? Yeah, please go ahead.
So it seems that some of these curves are going to be a little challenging because you mentioned, like for data availability, it could be you've got most of the data, there's just only 10% missing.
Yep.
But that 10% was the part that hooked the other data together.
Yep.
And so, where it could have been that a different 10% missing, well, you know, that means we can't do a certain feature, but we can still use the rest of it. So is there any, you know, is there a way that you...
Well, I mean, that's the challenge about my model. The real value of the model is coming from those desirability curves and how to make sure that we have values there that make sense. So that's the next stage in my research now. I'm done with the model. Now I'm building those desirability curves. I need to put initial values for them, and then I establish expert panels with backgrounds that represent different areas from city, from technology, from academia, and show people my results, saying that here's what I think that makes sense, what do you think? And then by using pairwise comparisons, I try to derive ways for those. So yeah, as you said, the smart way, the challenge about this is how can you write those values in a way that makes sense, so the model will make sense or it will not make sense. It's really tempting to just create, I would say, numbers, just to say, well, that integration complexity, it is simple, it's medium, it is high, but that doesn't allow us to learn much. And as I said, in my model, we need not just to score ourselves, but find out what do we need to do to enhance our score. So that's the challenge. This is what I'm working on now for all of those criteria. Some of them are easy, some of them are, yeah, as you said, challenging. Yeah, please go ahead.
I have a question on slide 24 on the readiness assessment. Have you given, it's my experience that a lot of these smart city or a lot of the innovative projects, some of them start bottom up, but a lot of them come top down, where a political official will say, we are going to do such. And have you given any thought to how this model might fit into that type of environment, or in this environment where where there's a political pressure to get a project done, or something?
Yeah, so I mean, I have a lot of experience in doing those projects outside the US, but also in government capacity. And what you are saying is absolutely right. There is always, when people call you and says, smart city is a nice thing, I need that tomorrow, the other city did that, we have budget, go ahead and do it. And how can you reason with those people? And in fact, maybe here in the US, there is some sort of democracy. You could sometimes discuss with people in other parts of the world. Sometimes discussion will cause you to challenge the problems for yourself. And this is why, again, I'm building a model. I found that talking and reason with people makes sense. If you just go to the top management and says, no, this is not doable. No, you don't know what you are doing, you are fired, bring somebody else. But when you bring a model like this one, and you start to tell them, okay, we can do this, but here are the challenges, here are the ways forward, here are the missing things. We can do this project for you, but let we fix 1, 2, 3, 4. If we fix 1, 2, 3, 4, then we can go ahead with confidence do it. Otherwise, the project might fail. So, when you talk with the top management with logic and reason they hear, and maybe here in the US also, like mayors, for example, there are elections. And of course, sometimes they do things like smart city to look cool and help them in elections. But when you show them what are the consequences, telling them you are not ready and you will end up wasting money and this will become a disaster, they will back off. Or they will tell you, okay, tell me what makes sense, where are the values. So structured models that allow you to see the big picture always help in talking to officials.
Might help you argue, if you want to do this, great, but we really need to.
Yeah, to fix 1, 2, 3, 4, yep.
Thanks.
Okay. All right, that's it. Thanks.